My name is Mr. Rene Costa, a PhD student of the Nelson Mandela African Institution of Science and Technology, Arusha, Tanzania. I belong to the Department of Material Science, Material Energy Science and Engineering. Also, I'm working at the Open University of Tanzania. This today presentation is about Visual Poster Session 1 to the Electronic Structure Workshop at the University of California, Merced. This project deals with Betanidin isomerizations and the decarboxylation, thermodynamic and charge transfer dye properties toward dye-sensitized solar cell application. The project is sponsored by the Wise of Future and the African Center of Excellence, funded by World Bank. This project deals with the two isomeric structure, the one with bent structure and another is planar structure. This isomeric structure shows the instability, which were well-known drawback on these dyes, which impedes the usage of the DSSC application. The study done through density functional theory and the time-dependent density functional theory computations. And the study covered the vibrational spectra from these structures, where the domestic structures show the isomers on the bent structure and the planar structure, where both of these structures show the ability to undergo the decarboxylation, where the loss of this CO2 from these two structures to provide the CO2, the carbon dioxide, and this decarboxylated product. Then the thermodynamic properties were studied from this structure, where the enthalpy at 0 in the ambient temperature and Gibbs free energy at ambient temperature were studied, where both reactions show the spontaneity of the reaction, and all these reactions shows the positive entropy. And the thermodynamic characteristics of the isomerizations were also studied. It shows that the Gibbs free energy was, when the temperature increases, it has these spontaneity increases, and the entropy and the enthalpies show the positive values. When the temperature increases, there are slight increase of these parameters. Also, for this pressure ratio of the isomers of these two isomers in this reaction 1 here shows that under this figure, that is, as the temperature increases, the pressure ratio of this planar versus bent increases. Also, this Gibbs free energy, as the temperature increases, the spontaneity of the decarboxylation reactions for the reaction 2 and reaction 3 were increasing. Also, the optoelectronic properties to this project shows that the entire molecular orbitals under vacuum were studied under these high molecular orbitals and the less and molecular orbitals, where these parts, the interest or where the movement of electrons to these two different states were identified. And also the charge transfer properties were studied, where these bent and decarboxylated. All the properties were obtained smoothly, while the planar structures shows the misbehavior on the optimization of the cut iron of this structure, shows the decarboxylation. That's why we didn't report here the whole organization energy on this molecule. Also, the UV spectra of these dyes were identified, shows the promising absorptions for the planar structures, although shows some instability on these charge transfer properties. However, the energy level diagram show that these two rather than these decarboxylated molecules, where this HOMO is above the redox potential of the electrolyte. The conclusions here insist that the bent structure is more stable energetically due to the hydrogen bond formations, and the thermodynamic approach insists the planar isomers appear to be more abundant in gas phase because of the entropy factor. That is, when the entropy is more positive, it means the structure is more favorable to be free in the reactions of the molecules. Both Betanidin conformants demonstrating the stability undergoing spontaneous decomposition of these carboxylated and the CO2. And both Betanidin dyes, these isomers, are suitable for regenerations where the carboxylated does not satisfy the criterion of dye regenerations due to the HOMO of these decarboxylated observed to be above these electrolyte potential. And we anticipate that the optoelectronic properties of these Betanidin dyes might be improved under other conditions when we introduce the pi spacers or linkers as modifications, which will be done whether through esterifications or other type of reactions. Thank you very much to participate in this workshop. I welcome again to the next days of the workshop.